we're going to run a hypothesis test for mean values. This is 10.3.13. We're going to use StatCrunch to do so. So under this situation, I've highlighted important information. What we learn is that a score of 24 suggests that a student is ready for college level math. So the null hypothesis is that the mean equals 24. Now, do these results suggest that students, after collecting sample data from 250 students, you get a mean 24.5, standard deviation 3.4? Does this mean that they are scoring above 24? Well, on this sample it is, but we want to see if this is true for the population. Is there enough evidence to say that the population is greater than 24 given these means and standard deviation, the mean and standard deviation for the sample of 250 students? So first we write the null alternative. Here are the requirements. All this is from notes here. The requirements for testing a hypothesis test using of means. And so once you have that, we're going to run a hypothesis test. We need the test statistic and the p-value. And using StatCrunch, in this case, we will go to t-stats for means. There's one sample, and we have the summary data. We know the mean is 24 from the sample, 24.5, standard deviation 3.4. So that's what we put in there, 24.5, 3.4 for the standard deviation. The sample size in this case was 250 students, 250. And what we're putting here is that the mean is equal to 24 and that it is greater than 24. That's it, and compute. And then with that information there, we get a test statistic of 2.33. How many decimal places? So you get 2.33. And then to the p-value, 3 decimal places, 0.010. So in this case, you get 0.010. Our alpha level, what is our alpha? Oh, let's see. Oh, test for alpha level 0.05. So in this case, what's going to happen is, since the p-value is smaller than alpha, we're going to reject. You reject the null hypothesis, we reject the null hypothesis and the claim that there is sufficient evidence. Since we're rejecting the null hypothesis, we say there is sufficient evidence to conclude that the population mean is greater than, because what we're saying is if once we reject the null hypothesis, once we reject this, we're saying that's true. And so that's where we come to this conclusion here.